Hi, my name is Dhruv and I'm a tutor at Tutor here. And this video is about how to solve a system of linear equations using the elimination method. So let's get started. So what we established in the previous video was what does a linear equation actually mean? And what does it mean to be a solution for a linear equation? And we came to the conclusion that a linear equation is represented by a line on a two-dimensional plane. And every point on that line acts as a solution for the linear equation. So what does it mean to be a solution for a system of linear equations, which means two linear equations? What does it mean to be a solution for that? So let's go ahead and see that graphically. What does it mean? The first linear equation is y is equal to negative 2x plus 8. And the second one is y is equal to 2x minus 4. And the solutions for these linear equations in the form of lines are plotted on this graph, as you can see in purple and blue. And you can see that these two lines intersect at a point 3, 2. This point is the solution for the system of linear equations. And this is the point that we hope to calculate algebraically through the elimination method. So let's go ahead and actually dive into the elimination method. Before going and solving it on an actual system of linear equations, let's actually build our logic and let's build the elimination from the ground level. So if you recall from the previous video, we have a linear equation and it has two variables, x and y, and that is why you have infinite solutions, because the pair x and y can take multiple values. So you have infinite solutions for one linear equation. Now, to get a constant term, you would want a single variable in an equation. And let's actually prove that through an example, which is x minus 3 is equal to 1. What we want to prove is that this equation, which has a single variable, gives out a constant value, which we want. So to solve this, you would add a positive 3 on both sides. So let's go ahead and do that. So 3 on this side and on the other side. So it'll be x minus 3 plus 3, which will give out an x. So it's negative 3 plus 3 is equal to 0. And 1 plus 3 is equal to 4. So here we've established that an equation which has a single variable is going to give out a constant solution. So this is what we want to turn our linear equation into. Now, this would mean that we would have to eliminate either x or y to actually get an equation which has a single variable. So how do you do that if you're given two equations? So let's go ahead and see that through another example. So here we have the first equation, which is ax plus by is equal to c, and the second one, which is ax is equal to 4. Now you want to eliminate one of the variables from equation 1 to obtain an equation which has a single variable. Now, how do you do that using these two equations? The answer to this is that you can either subtract or add these two equations. Now, you might ask, is that even valid? Can I add or subtract two equations? And I would say, yes, it's completely valid by the simple fact of this operator sign. Because ax is equal to 4, you can add and subtract equations. So what that means while you practice it out is that you would subtract ax from the left-hand side of the first equation, and you would subtract 4 from the right-hand side of the first equation, and that would be completely valid because ax and 4 are the same value. So let's actually go ahead and do that to actually eliminate the x variable. So if we go ahead and do ax plus by minus ax, you would get by because ax minus ax would give you a 0, and you would do c minus 4, which would give you c minus 4 on the right-hand side, and you have successfully eliminated the x variable term to get a single variable in an equation. And that is the framework we would use to actually solve it on a system of linear equations. So let's go ahead and solve it on the system. So here's the first equation, which is negative 3x negative y is equal to 3. And the second one is 3x minus 2y is equal to 6. So when I look at these equations, I have to decide, should I add them or should I subtract them? The moment I look, I see a negative 3x and a positive 3x. So what I'm going to do is I'm going to add them because I want to eliminate the x term. So let's go ahead and do that. Let's add a positive sign. And let's go ahead and add these two equations. So negative 3x plus 3x would give you 0. So you have successfully eliminated the x variable, right? You go ahead minus y minus 2y, which gives you a negative 3y. Let's go ahead and write that. And you would get 3 plus 6, which would be a 9. To solve this further, you divide both sides by negative 3. So ultimately, you would get your y value as negative 3. So here you have successfully calculated the y coordinate for this system of linear equations. Now, how would you calculate the x coordinate? You can simply calculate it by substituting the value of y either in equation 1 or equation 2. So let's go ahead and do that in equation 1. So let's substitute y is equal to -3 in equation 1. That'll give me minus 3x. Okay. And you have a negative y. So negative times a -3 would give you a positive 3. Negative times negative is positive. There you go. And that is equal to 3. Next operation you perform, you see 3 on both sides. So let's subtract 3 from both sides of this equation. So you would have a negative 3x plus 3 minus 3. So that would give you a 0. And the same is for the other side, which is 3 minus 3 would again give you a 0. So finally, you want to go one step further, you calculate the x value, which would be equal to 0, simply because of the fact that anything divided by 0 is going to give you a 0. So here you've calculated your solution for this system of linear equations. So let's go ahead and put it in a nice color. So the solution and the answer for this system of linear equations is 0, minus 3. So here is your solution, your final solution. So let's actually go ahead and actually plot these two linear equations on the graph and see, do they intersect at this point 0, minus 3? So let's go ahead. All right. Keep it orange. So the first equation is minus 3x minus y is equal to 3. Let me take the y value as 0 first. If y is 0, you'll get a negative 3x is equal to 3. Divide negative 3 on both sides, and you get x value as negative 1. Let me take the y value as 3 this time. So taking it as 3, it'll be 3x is equal to 6. So x will be equal to negative 2. So there we go. And let's go ahead and do it for the next equation, which is 3x minus 2y is equal to 6. Again, let me take, sorry about that. Let me just get that out of the way. Yeah. Let me take y value as 0. So it'll be 3x is equal to 6. So it'll be x is equal to 2. There we go. And let's take the next y value as 3. So it'll be 3x is equal to 12, which would mean x is equal to 4. So here are our coordinates for the system of linear equations. Let's go ahead and plot that out on the graph. Let's put a green color for this, for the first equation, which is -1 and 0. So here is -1 and 0. There we go. The second point is -2 times 3. -2 times 3, right around here. So here are our plots. Let's change the color for the next one. Let's go ahead with the red. Right. So the point for this is 2, 0. So let's go ahead with 2, 0, right about here. And the next one is 4, 3, which is right about here. All right. So all that's left to do is actually plot these lines so that we can see, do they converge on the point that we are after, which is 0, -3. So let's go ahead and draw these lines. All right. Here it is. This is the first one, first equation. And here it is for the second equation. All right, let's actually get yeah. All right, so here we have it. We have these two lines, and as you can see, these two lines intersect on the point which is 0, -3. So this matches the point that was the solution for our system of linear equations, and we have proved it on this graph right over here. Thank you so much for watching this video. If you have any questions or comments, please leave them down in the comment section, and I hope to see you next time. Thank you.